Hello everyone, how are you people? I am back here again with a very new session of Strate-JEE. I suppose all of you are doing good, doing well at your homes. So जल्दी आ जाओ यार, हुए जितने भी लोग हो आप लोग, all your friends who all are waiting, जल्दी मुझे chat list में बताओ how many of you are waiting. Hi, hello, anything? I just want to see your presence over here. एंड हम बहुत ही जल्द सेशन स्टार्ट करने वाले हैं. हमारा बहुत इंटरेस्टिंग सेशन होने वाला है. टॉपिक यू ऑल नो, इट इज अबाउट ग्रेविटेशन. वेरी ब्यूटीफुल टॉपिक, वेरी इंटरेस्टिंग टॉपिक. बेसिकली यू कैन जस्ट फील whatever is happening in outer space with the help of this topic. So it is going to be an amazing session right here, right now, and in the next 1 hour we'll be discussing about all the previous year important questions. So maximum will be the recent years one, because they are the trend right now and they can tell you what type of questions you can actually expect when you are about to go to the exam and get questions about gravitation. So we'll be dealing with all those questions in this next 1 hour. I want all your presence over here, all your attention for the next 1 hour, wherein I'll be discussing about all the important things. So you all must be knowing about this series, right? Strategy, wherein we are discussing previous year questions, previous year important questions, and which have been asked, and maximum students have faced difficulty in it. So the selection of our questions has been like that only. So wherever students have faced maximum difficulty, or that error quotient, which I'll be discussing it with you as well. So what all problems students have faced, and in what all scope basically students have done some mistakes or the other. So we'll be discussing about all and each and everything over here. लेकिन first आप सभी जल्दी से आ जाओ. I want all your attention screen की तरफ, ठीक है? So you all must be knowing about the strategy sessions. बहुत सारे sessions हो चुके हैं. These are live webinars basically for you people, जिसमें हम previous year questions करते हैं. We'll be telling you about perfect strategies. Then इसके साथ साथ कुछ tips, tricks के साथ how can you find the answer in a very limited time frame. So all these things are discussed over here. साथ ही साथ the best part is we actually give you an error analysis as well. That is, कौन से questions में ज़्यादा probability होती है गलती करने की, और कहाँ आप ज़्यादा गलती कर सकते हो. So the discussion is very fruitful, and the next 1 hour won't be a waste for you. The ROI of your time will definitely be very good. Okay, so let me give my introduction to you people. My name is Adarsh Rai. I'm a graduate from NIT Bhopal, and I have been mentoring students for past 6-7 years, and I love teaching basically. I love teaching this subject which I am presenting in front of you. It's a very realistic subject. I basically feel physics, and that's the reason I am standing in front of you and telling you all the concepts of physics. Okay, and if I talk about Extramarks, so Extramarks is a very good name with its rank. 1 out of every 7 candidate has secured a good rank in JEE Main, and we are sure that this figure is going to increase in the coming days, in the coming weeks, in the coming years as well. Okay, and about the content, basically I'll be sharing it with the details about our app. So for the time being, if you can check in the description, you'll find the link of Extramarks learning app, which you can download it right away. It is on both the platforms, iOS as well and your Android as well. And on downloading it, what you'll get is you'll get plenty and plenty of questions depending on whatever topic you like, whatever topic, subtopic, whichever class you wish for, you can get questions based on that. Okay, and the content is not just random. It has been specially curated by experts, and that too which already have cleared this exam, who already are IITians and NITians. They have sat down and they have specially curated this content for you people, and it is very specific. It is curated in such a manner that it is very much accurate to the amount of questions, to the variety of questions which are being asked in present day by NTA. Okay, so do give it a try, boss, because you will definitely like it. You will definitely like it, and after giving those tests and practicing those questions, I'm sure you will definitely feel that yes, my preparation has escalated to a next level. Okay, now with this, let us start our topic. So basically these all topics, energy of satellite, Kepler's law, as these topics are you can view them, these are the hot topics of gravitation, and maximum times the question have been asked from one of these topics only. So here also I have selected the questions which are mostly from these topics, and we need to stress more on these topics whenever we are studying gravitation, because from these topics so many questions have been asked from past so many years. If I take the record of 2020 only, so from gravitation there were so many sessions, so around 1 to 2 questions you have been experiencing. More than that, some concepts of gravitation also have been asked in some other topic as well. Okay, and the best part about gravitation is, I'll tell you very clearly, you all must have studied electrostats, right? So many concepts of electrostats and gravitations, they just merge together. You can just create a similarity between them, okay, because they both are the forces which are dependent upon the inverse square law. So in that sense, all the gravitational field concept, electric field concept, the potential energy, in both the cases is almost the same. So having an perfection in electrostats can definitely give you a perfection over here in gravitation as well, or vice versa. If you have perfected your gravitation chapter, then I am sure that you will have a great edge whenever you will be practicing questions or studying electrostats as well. Okay. So let me bring in front of you the first question, and the first question is from JEE Main 2020. So what this first question says is, the mass density of a spherical galaxy varies as k by r over a large distance r from its center. So we live in a galaxy, right? Our galaxy is Milky Way galaxy, right? And there are so many galaxies distributed in our universe. So this question is about any such galaxy wherein the density is not uniform. Mass has been randomly distributed and its mass is increasing, not increasing, it's decreasing as we are moving away from the center, and here goes its density like that. So as you can see, the mass density is inversely proportional to r, and r is what? The distance from the center. So as you increase the r, the less is your density. And what do we mean by that? We mean by that is as we move away and away from the center, the amount of mass residing in a particular volume is decreasing. Okay, so this was just the analysis part. Now let's solve the question. So in that region, a small star is in a circular orbit of radius r. So okay, the star is performing a circular motion and it has a circular orbit. Then the period of revolution t depends on r as. So we need to find basically what is the relation between t and r, and not the relation exactly, we just need to find how t is changing with r. So that's what we need to find. Okay, so now let's move ahead and draw a diagram first, right? So what we can deduce from here is that suppose here is the center of our galaxy. Okay, here is the center of our galaxy, and our galaxy is, consider it to be a sphere, okay, and its density is increasing as we go radially outward, and here lies our star, one of the star, which is in circular orbit. Okay, so now the motion of this star around the center of the galaxy will obviously, because of the mass which is inside this circular pattern or inside this spherical pattern, because obviously we are imagining in a three-dimensional space, right? So this entire region is just a spherical shell. Okay, so whatever mass is inside the spherical shell will obviously exert a force on this star, and because of that force only this star will perform a circular motion. Okay, that force only, वो जो force है वही आपको centripetal force का काम करेगा, and that centripetal force will make this star to move in a circular orbit around the center of that galaxy. So what about the outer mass, sir? So basically, if you people can just create a similarity between the Gauss law. So the Gauss law says basically mass which remains outside, basically the electric field, or over here we can just introduce the concept of Gauss law. So the gravitational field over here will be zero because of the outside mass. That is, there will be definitely mass distributed over here as well, here as well, here as well. So this mass will have a null effect on creating a gravitational field on this star, right? So there won't be a force because of the gravitational field of this outer region of mass on this star, right? So यहाँ पर जो ग्रेविटेशनल फील्ड होगी वो बस इनसाइड मास की वजह से होगी. सो वी नीड टू कैलकुलेट दैट ओनली, राइट? इसकी वजह से, इस मास की वजह से यहाँ पे कितना फोर्स लगेगा, दैट ओनली वी नीड टू कैलकुलेट. एंड इफ वी आर एबल टू कैलकुलेट दैट, then we can clearly equate it with mv square by r, and then our approach will be very simple. So let's first calculate the mass which is residing. Okay, so what is the mass which is basically inside this spherical shell? Can you find that? Yes, we can definitely. Let's do in such a manner. So what we'll do, I'll go a distance r and I consider a very small spherical shell, okay, whose width is dr. Okay, on moving r distance from the center, I am just considering a very small spherical shell whose width is dr. Now, there must be some dm mass residing in it, right? There must be some dm mass. Now, what is the value of that dm mass? Can I just specify it up? Yes, I can definitely do that. So, that dm mass will definitely be rho times dv. Okay, where dv is nothing, it is the volume that is occupied by this small spherical shell whose width is instead dr. Okay, now what will be the volume of this small spherical shell? So obviously it's the inner shell, ये जो अंदर वाली shell है, इसका जो surface area होगा that will be 4 pi r square, and 4 pi r square को if I am extending dr length in all the directions, then that entire dv can be represented as 4 pi r square dr, right? So जो dv की value आ जाएगी that will be 4 pi r square dr. So dm can be specifically written as rho times 4 pi r square dr. Now this is basically the approach to calculate the mass. Now in maximum cases the density remains same, right? Or whatever case we counter with has the density as constant throughout the regions, throughout the radial length. But in this case the density is not constant and it is depending upon r. So we need to replace that k by r over here, and we need to calculate this entire mass. So what I'll be doing, I'll be replacing this k by r over here in place of density, and I'll be integrating on both sides, and the limits will be from r is equal to 0 to r is equal to capital R. That is the radius of what? This radius of the circular orbit which this star is performing around the center of that galaxy. Okay, so it's a pretty simple thing. Now we just need to integrate it, just replace rho by k by r, and 4 pi r square dr, and here also the limits will be from 0 to r. So here the entire dm integration will be the total mass value. Okay, so the total mass value is actually coming out to be, as you can see, this r will get cancelled with this r, 4 pi k will come outside, here r dr integration will come out to be r square by 2. On replacing the limits, you'll finally get capital R square by 2. So what this turns out to be is 4 pi k into capital R square by 2. So this is actually the mass which is residing inside this R volume. Okay, this R, capital R volume has a mass like this. Okay, so now what will be the next step? So the next step will be, I'll consider this entire mass to be concentrated about the center of the galaxy. Okay, and because of that, what I can finally conclude is, what I'll do, I'll just consider that the entire mass is concentrated about it, and this star of mass small m is orbiting in a circular orbit around it. So what will be the gravitational force on that star? The gravitational force obviously will be G capital M small m upon R square, right? True? Okay, it is free of cost. Yes, it is free of cost. Obviously it is free of cost. You don't have to give us a penny, right, for just viewing it. The investment from your end is your time. Okay, you don't have to pay anything. You just have to attend these lectures, and equally you have to attend the crash course lectures as well, which are daily happening at 5 p.m. So they'll be very helpful in your existing preparation. Okay, very recently the NT will be releasing the notification, so then it will be a race kind of a situation for you people. So you have plenty of time right now. Just prepare your whatever existing preparation you're going on, okay? Just escalate it. Okay, so the gravitational force acting on this star will obviously be G capital M small m upon capital R square. Now this force instead will be providing the necessary centripetal force. So what I'll be doing, I'll be replacing it with mv square by r. Now what I need to find, I need to find period of revolution t, right? So I won't be replacing it with mv square by r. I'll be replacing it with m omega square r. Okay, and the reason being because I can replace this omega by 2 pi upon t. Right? On replacing this omega by 2 pi upon t, I can finally get a relation between t and r. Is it clear? Yes, it's clear, sir. Okay, so now just replace it, G capital M small m upon capital R square. Also just write this capital M, we have just calculated this capital M, right? We know the value of capital M. So just place it over here. What is the value of capital M? 4 pi k r square. Just cancel it up, it will turn out to be 2 pi k r square. So 2 pi k capital R square. Okay, so this is the relation. Okay, no problem. So this R square gets cancelled by R square. Just leave the other terms. We just need to find the relation between time and R. So this omega square can be written as 2 pi upon t. So this will be R by t square is equal to constant. So what I can finally deduce is that t square is coming directly proportional to R. So was this an option? Yes, it was an option, so the answer is B. And are we correct? Yes, we are definitely correct. So just tell me how many of you did this question right. This was asked in JEE Main 2020. It wasn't a very tough question. It was just about visualization. Were you able to visualize this? Were you capable enough to consider this case wherein the density is not the density is not constant. Basically, it's changing with R. So this was the case just over here. You just need to introduce a section of calculus in it and find the value of mass. Rest, the entire case had been same. Okay. So this was all about JEE Main 2020, this question. Now let's move ahead and solve this question. So ये question क्या बोल रहा है? Okay. So this question says that a height h at which the weight of a body will be the same as that at the same depth h from the surface of the earth is. Okay. So if you all have studied gravitation, you all must have definitely understood this case of change in acceleration due to gravity when I go a height h up above the surface of earth, when I go a depth d down below the surface of earth, and also acceleration due to gravity changes because of the rotation of earth even, right? So you all must have seen. Now what this question says is that at height h, whatever is the value of gravity, and at depth d, whatever is the value of gravity, okay, they both are same, then just find, what we need to find is that what is the value of h, right? The height h at which the weight of the body will be same as that at the same depth h. Okay, so we just need to find the value of h, that same h and d, whatever it is, in terms of r. R is what? It is the radius of earth. So it's a pretty simple case. We just need to equate acceleration due to gravity at height h with acceleration due to gravity at depth d. Okay, so on just equating it, we'll be finally getting the relation of h in terms of r. It's pretty simple. We don't have to do anything other apart from that. So can you just help me with what is the value of acceleration due to gravity at height h? It's pretty simple, right? So what will happen whenever I go at a height h, suppose this is height h and this is radius r. So now the force, the gravitational force acting between me and the earth will be G capital M small m upon r plus h whole square, and instead that will be actually acceleration due to gravity. Okay, so G capital M small m upon r plus h whole square, and this is what? This is my weight even, and if I just calculate G capital M upon r plus h square, that is acceleration due to gravity, and if I multiply it with small m, then that becomes my weight. So basically they are talking about weight. So I have written the weight, and this is the weight at height h. Now what will be the weight at depth d? Okay, so at depth d, when I go a bit deeper inside earth, so now the distance between me and the center of earth now will be r minus d. And as I told you in the previous case, the outer mass will not be affecting or not creating a gravitational field on me. The net gravitational field on me will be equal to 0. So the entire force which I will be experiencing, pura ka pura force, the entire force will only be because of this internal region only. So मुझे यहाँ पे इस m की जगह इसका mass रखना है. Are you getting my point? I just need to replace this mass over here, and the distance will be r minus d whole square. So the scene remains same. It will be g m dash small m upon r minus d whole square. Now what I need to do? I just need to replace this m dash with this mass. So now what will be this mass? So as mass, the density remains same. We are considering the cases wherein we are not changing the density of earth. Okay, so from surface to the center, the density of earth remains same, and there only these relations have been determined, or else these relations will not survive if density is different, as was in the previous question. Okay, so now what I just need to do, I just need to replace m dash by rho, that is the density, into the volume. This is this volume, okay, the volume of the inner sphere. So that will be 4 by 3 pi r minus d whole cube. Okay, and same thing I can do over here as well. I can replace this capital M by rho into 4 pi 3 pi capital R whole cube, because this is the mass of the entire earth, and in doing so some elements will get cancelled up, and finally we will be remaining with only h, d and r. Okay, and obviously one more thing, h and d both are equal, as they have said. The depth is also same, the same as depth d. Okay, so depth is same, height is same, so both h and d are same. I will be just replacing d by h only. Okay, so on doing that, just look it over here. So d, gm gets cancelled, replace mass m by rho into 4 by 3 pi capital R cube divided by R plus H whole square, and this will turn out to be m dash is what? M dash is rho into 4 by 3 pi R minus D whole cube, right, divided by R minus D whole square. Okay, fine, no problem. So rho 4 by 3 pi, rho 4 by 3 pi also gets cancelled, and also I can replace this d by h also, right? And this r minus d square, can you see that it gets cancelled with this and only r minus d is remaining over here? Just replace this r plus h square over there. Just expand it up and let's see what the equation is finally turning out to be. So the equation turns out to be r cube is equal to, okay, it is r minus d, right, r minus d into r plus h whole square. So r plus h whole square. I just need to expand this, right? I just need to expand this using a plus b whole square, and what this will turn out to be, let's see. So r square plus h square plus 2hr. So expand करने पर जो relation आ रहा है, that is coming out to be this r square plus h square plus 2hr. Now what we need to do, we just need to multiply it and cancel करेंगे. Let's see what the relation is turning out to be. फटाफट करते हैं. r cube आ जाएगा इधर, r को यहाँ multiply करो, this will be r cube, इससे आएगा तो plus h square r, इससे जाएगा तो plus 2h r square, okay, and d से multiply, okay, this d is nothing, this d is h instead, so just replace it with h, just replace it with h only. On replacing this d with h, what we are getting is यहाँ पे आ जाएगा एच आर स्क्वायर, सो माइनस एच आर स्क्वायर माइनस एच क्यूब एंड देन minus 2h square r. Okay, fine, perfect. This r cube will get cancelled with this r cube. Okay, anything else? Yes, one h can also be cancelled up. And acha, बाद में we'll do the 1h cancellation. First let's see this h square r. Is there any term as h square r? Yes, there is. This h square r. Okay, there is hr square. Is there any term? Yes, this is hr square. So what I can do is this h square r minus 2h square r. So it will come over here and it will instead become plus h square r, and this h cube will also come over here. So h cube plus h square r, and this 2hr square minus hr square. So it will also turn out to be, and it will come over here. So it will become minus hr square, and it is turning out to be 0. Okay, just eliminate one h and equate it with 0. So finally you will be getting a quadratic equation like this: h square plus hr minus r square is equal to 0. Okay, so this equation, this kind of an equation you will be getting up, and finally what we can do is I can find the value of h using quadratic formula, and that becomes very simple, right? So h will be nothing, it will be equal to minus b plus minus under root of b square minus 4ac upon 2a. So what is minus b? Minus b will be minus r plus minus under root of b square. What is b square? It is r square. So r square minus 4ac. So 4a is 1, c is minus r square, that turns out to be plus 4r square, okay, divided by 2. Now what this is turning out to be, so over here you can get two values of h if considering plus and considering minus, and obviously you won't be considering minus. You're not a fool to consider minus, because in that case our h will become entirely negative, and h cannot be negative. If h is negative, then what is our case going on? H has to be positive, right? So we'll be eliminating this negative sign and keeping only the positive sign. So finally our h will turn out to be, this is a very good availability to you people. You can ask your doubt instantly. I'll be clearing them right here, right now. Whatever is your doubt regarding this gravitation or anything else, okay? So now let's move ahead, and if you are loving these kind of questions, if you are interested in more such engaging videos, kindly subscribe to this channel. Also like this video, because we get to know how much you are liking the video, so that we can improvise also. Getting a dislike or not getting likes actually make us feel that we are not creating good content, and what we do in that case, we just make it much better, okay? But we need those likes as well, okay? So kindly like this video. Also, if you think these videos are helpful to any of your friends, do share them to all your friends. And one important thing as well, we have been receiving so many queries from your end, so many requests from your end, that kindly conduct the sessions in English as well. So we have decided that our entire sessions from now on will be 80 to 70% in English, and there will be a pinch of English as well in it. So maximum the lecture will be in English, and I suppose that will be really helpful for you people in your ongoing preparation. Okay, so this will be the answer for this question asked in JEE Main 2020. Now let's move ahead and talk about this very beautiful question, and I'll be telling you a very good thing over here as well. And this is actually a very nice question, and so many students don't know actually what will be the trajectory of a satellite. So the only trajectory existing in their mind is circular path. So it isn't, right? It never is. Or the other one is elliptical path. But the trajectory of the motion of a satellite can be in 4 ways instead in 5 ways. And depending upon the velocity, what will be the trajectory? Those things I'll be discussing in this question. So it's a pretty nice question. Just look over here. So what it says is a body A of mass m is moving in a circular orbit of radius r. Okay, no problem. Around a planet. Okay, so around a planet, a body A of mass m is moving. Another body B of mass m by 2 collides with A with a velocity which is half v by 2. Okay, the instantaneous velocity v of A. So what they mean by this giving this vector sign also over here is that the direction of both these velocities, v by 2 and v, both these velocities, the direction is same. So basically collision is occurring in such a fashion that here is one particle, suppose it is m and this is m by 2. So m by 2 is moving in this direction with a velocity v by 2, and also m is also moving in this direction with a velocity m. So they both have the same direction, and after collision what they do is, the collision is obviously inelastic, so what they'll do, they'll get stuck to each other and then move with a common velocity, and this will be the case over here. Then the combined body will follow which trajectory? Okay, so they are asking the combined body will follow which trajectory? Already there was a mass A, it was following a circular orbit. Now on collision with any other object, that is the mass of m by 2 and having a velocity v by 2, they make an inelastic collision, that is they get submerged with each other and now they move with a common velocity. Okay, so the cases of inelastic collision, they make a single body, they move with a common velocity, and now with that velocity and 3m by 2 mass in hand, what will be the trajectory? Basically they want to know that. Okay, so let's solve this question. First let's analyze what is the velocity, what is the common velocity which they both will have after colliding with each other. So the case I've just given you the example. So suppose this is mass m and it was moving with a velocity v, and here it is mass m by 2 and it was moving with a velocity v by 2. They both collided with each other, and on collision they got stuck to each other as occurs in inelastic collision. So on getting stuck with each other, the entire mass now becomes 3m by 2 and it will move with a common velocity v dash. Pretty clear? Not an issue with this. Okay, so what will be the value of this v dash? What will be the value of this v dash? We can actually use the concepts of collision, right? Concepts of collision are basically the conservation of momentum concepts, and it can surely give us the value of v dash, right? It can surely give us the value of v dash, and that can be calculated that 3m by 2 times v dash will be equal to the momentum of this mass plus the momentum of this mass. So what it will turn out to be mv plus m by 2 times v by 2, and what this is turning out to be, just have a look over here. So this m gets cancelled, it turns out to be 5v by 4, 2 se 2 cancel ho jayega, 3 will come over here. So finally the v dash will turn out to be 5v by 6. Am I correct? Let's check it again. So this will turn out to be 5v by 4 and 2 cancel, 2 will revere. Okay, 5v by 6, perfect. I got the right answer. V dash is equal to 5v by 6. So the answer is finally V dash is equal to 5v by 6. Matlab, this 3m by 2 will have a velocity of 5v by 6 and it will move. It will definitely move. Now, how to tell what trajectory it has? So for that, I'll be giving you a very good trick. Now what happens is, whenever a satellite is released, so it is released in vertical direction, but because of the rotation of Earth, it is imparted with a horizontal velocity even. So this is a very good question to you people. Do you ever imagine, or have you ever seen or noticed why all the major launch stations are equated near the equator? Just give it a try. Don't Google it up. First, let's think of it, that why major launch stations are located near the equator. if I talk about Indian Space Station or the French Guinea of France, so all these stations basically are located near the equator. And what is the reason behind that? So give me the answer in the crash course section, where I'll be discussing about gravitation only. But I just want to make you people aware about that. Ki what happens is, whenever a satellite is launched, it is imparted with a velocity on ground, and when it reaches a height, then also it is provided with a velocity. So basically the concept turns out to be that if a satellite has a velocity, let's say v, if a satellite has a velocity v over here, now if v has a velocity equal to vu, that is the orbital velocity, then what will the satellite do? It will follow a trajectory circular in fashion. It will have a circular trajectory. So for such a case, the trajectory will obviously be circular. Okay. Now what if it has a velocity greater than vu? So if it has a velocity greater than vu, that is orbital velocity, but lesser than its escape velocity. So this velocity is obviously lesser than its escape velocity. Then the path of this satellite will be elliptical in nature. Okay, it will be what? It will be elliptical in nature with the planet being that point wherein basically the planet will be situated at one of its foci, and the foci will obviously be the farther one. Okay, so the distance will obviously be like this. So the perigee point will lie over here and the apogee point will lie over here. It will occur when velocity is greater than vu but lesser than v. Now if the velocity becomes equal to v, escape velocity, then what will occur? What will be the path of the trajectory? Okay, so the trajectory in this case will be parabolic, and it will obviously leave the influence of Earth. So it will obviously move like this. It will leave the influence of Earth, definitely. Now what if it becomes greater than v? So then in that case also it will leave the Earth, but the trajectory will now turn out to be, what? Hyperbolic. Okay, so these are the trajectories. Okay, sir, there can also occur a case, right, that v is less than vo. And what will happen in that case? So if v is less than vo, in that case also the trajectory will be elliptical only. And in that case there occurs a chance that it can collide with Earth or it cannot. So basically in this case the apogee point, that is the distance, the more distant part is over here and the least distance part is over here. And in this case what happens is this becomes the perigee and this becomes the apogee. Okay, so in this case this becomes the perigee point and in this case this becomes the apogee point. Okay, so in such a fashion, in this case also elliptical path are here. Okay, now we are provided, so this was the conceptual part. Now what we are given with is the velocity is given to us as 5v/6. So this velocity, and presently it is at a distance of r, right? What is the distance? It is at a distance of r, circular orbit of r. Now over here, what is the value of orbital speed now? So what is the value of orbital speed? So it will obviously be equal to gm, and this is basically v. So v is what? It was initially moving with a velocity v, right? So v is obviously what? Orbital speed. So v is under root of gm by r. So it was given to us the orbital speed is v and it is nothing, it is equal to gm by r. The radius, the distance, the radius of the circular orbit which it was following. Now what will be the value of escape velocity over here? So escape velocity is always root 2 times v. Okay, root 2 times the orbital velocity, so it will turn out to be root 2 times v, and that is 1.41 times v. Now where r velocity is lying, basically where r velocity is lying with this mass. Now the mass also has changed. Okay, the mass also has changed. So our velocity is 5v/6. So where it lies, 5v/6 is obviously lesser than v, right? It will be 0.8 something, 0.8 v. Now this v dash is obviously lesser than this velocity, and if it is lesser than v, this velocity, then you all know the case. In the case when v is lesser than vo, then also elliptical path is occurring, and in the case when v is greater than vo, then also an elliptical path is occurring. So finally our answer turns out to be the path of the trajectory will be elliptical. Okay, okay, so Arshdeep, you have a doubt, So what doubt you have, Arshdeep? Ask it finally. And sir, worksheet how to access? Okay. Worksheet, which worksheet you are basically telling about? Johnny, please be specific which worksheet you are telling about. I'll just let you know. So I think you people got this answer, right? So over here, if the velocity is lesser than VO, then also an elliptical path is occurring. And if the velocity is greater than VO but lesser than VE, then also an elliptical path is occurring, but only the perigee and apogee point changes. Okay, so in this fashion also it will have an elliptical path, and if that elliptical path is fine enough, so it can actually make a revolution around Earth. Okay, if the elliptical path is somewhat like this, suppose here is Earth and it was at this point, so if it is fine enough, so it will just graze this surface and be enough to have a revolution, or else if it is not fine enough, then it will collide somewhere over here on Earth, but the path will be elliptical. Okay, so I suppose you people have got the idea how we can decide which path it will be. Okay, so this is, and what about the straight line path? So when will the straight line path occur? So straight line path, can it occur? It can occur only in one case, if its velocity becomes momentarily zero. If its velocity becomes momentarily equals to 0, then it will have a straight line path and fall exactly down below its point where the collision had occurred. Okay, so in such a cases, straight line path will occur. Now let's move ahead and solve this question, a pretty simple question. So what it says is, a satellite is in an elliptical orbit around a planet P. It is observed that the velocity of the satellite when it is farther from the planet is 6 times less than when it is closest to the planet. Okay, fine. The ratio of distance between the satellite and the planet are at closest and farthest point is. So this is a classic case of Kepler's law. Okay, the Kepler's law, what it says is the angular momentum during a planetary motion around a star is always constant. So in this case, the angular momentum remains same, and what they are saying is they are talking about the velocity, right? So velocity 6 times less than. Now what we need to find is, we need to find the ratio between the distance, and the case is pretty simple. Suppose this is a star, and in an elliptical orbit, what happens? There is a perigee point, there is an apogee point. The perigee point is the one with it is closest to the star, and the apogee point is when it is farthest away from the star. So what happens in a planetary motion is that angular momentum remains same. So whatever is the angular momentum over here, it will be equal to here. Suppose the velocity over here is VA, and over here is VB, and the distance over here is RB, and distance over here is RA. So M into VA into RA will be equal to M into VB into RB, and this is what angular momentum at A will be equal to angular momentum at B, even in magnitude, even in direction. Okay, even in magnitude, even in direction, the angular momentum will be same. So what we can do, we can just cut this M, and simply we need to find the value of RA is to RB, right? So this will in turn be equal to VB is to VA. Okay, and what is VB? At the farthest point it is lesser, right? 6 times less, and it is so this will instead be VA by 6 divided by VA, and it will turn out to be 1 by 6. So is there an option? Yes, it is, and it's a very simple one. I suppose you all must have got what this answer says. So in these classes only questions will be solved. Yes, Shubham, these classes are only wherein we'll be discussing about previous year questions. So obviously, as the description says, previous year questions means previous year questions of JEE Main and JEE Advanced. So only questions will be solved over here. If you want to have an info about the conceptual part, then what you need to do, you need to subscribe this channel. Okay, you need to subscribe this JEE Extramarks channel, wherein daily at 5 PM we are conducting live sessions of crash course, and in that portion we'll be giving you the entire conceptual knowledge. Okay, apart from that, you can also see our amazing webisodes. Okay, amazing sessions over here, wherein so many topics have been discussed in such detailed manner, so you can also view them. Okay, so there are so many things on the platform, on the channel. Kindly give it a look and you will definitely like it. Shubham, I just told, na, theory part will be covered in the crash course. So for that part, you can subscribe to this channel and actually watch the ongoing sessions which are occurring daily at 5 PM. Okay, now let's move ahead and solve this question of twin star system. Twin star system. Okay, so two stars of masses 3 into 10 raised to the power 31 kg each, and at a distance 2 into 10 raised to the power 11 meter rotate in a plane about their common center of mass O. So what happens is basically because of gravitational force, what we obviously get a feel is that sun isn't moving and earth is revolving around it. But actually what happens is, whenever two masses are situated, okay, whenever two masses are there, they rotate, or basically they revolve about their common center of mass. Okay, such kind of whenever they are in rotation, whenever they are in motion, so basically what will happen is they will always revolve around their common center of mass. So when I talk about Earth Sun system, so their common center of mass is inside the Sun. Reason being, Earth is so less massive as compared to Sun. But when I talk about Jupiter and Sun, then their center of mass is obviously outside the Sun. So if Jupiter and only Sun are in action and they are moving around each other, then even Sun is revolving around the common center of mass. And this thing is evident in these twin star systems as well, when two such bulky stars, obviously bulky, and both have a mass 3 into 10 raised to the power 31 kgs. So what will happen? One of the stars will not revolve around other star. They both will revolve around their common center of masses. And since in this case, the both mass is same, so the common center of mass will lie at the midpoint of the line joining them. Okay. And obviously their distance are 2 into 10 raised to the power 11. So basically the midpoint will be 10 raised to the power 11 from each one of them about their common center of mass. So a meteorite passes through, moving perpendicular to the star's rotation plane. Okay, no problem. In order to escape from the gravitational field of this double star, the minimum speed that meteorite should have at O is. Okay, I'll just explain here. Okay, so what happens is these type of questions wherein diagrams are not provided to us are obviously very difficult. Because what happens, so many times the person is not able to imagine what case is actually happening. And this is what the problem was with this question, that students weren't able to imagine what kind of a case they are actually telling us. And the case was very simple. Instead of these very big masses, you could also consider two identical small unit masses and then also solve this case, and it remained same. But given these figures and what was their rotational plane twin star system, and people got confused and they just left this question, and it was pretty simple as well. So I'll be just solving this and telling you how we are going to proceed over here in this question. So what happens is, suppose this is our horizontal plane, right? This is our horizontal plane, and what happens is there are two stars. Okay, obviously they are located 2 into 10 raised to the power 11. So basically their common center of mass will be over here, and it will be at a distance of 10 raised to the power 11 from each one of them. Okay, and their individual masses you all know. Let it name them as small m for the time being. Now a meteorite has to pass. There is a meteorite, it has to pass through its common center of mass. So this meteorite has to pass through their common center of mass. Now what they are saying is, in order to escape from the gravitational field of this double star, the minimum speed the meteorite should have is. So basically because of them there will be a potential energy over here, right? And what do I get a concept whenever I talk about escape velocity is that object should entirely leave the gravitational influence. That means the potential energy, and when it occurs when the object is at infinite distance from whatever source you are considering. So over here we have the sources as these twin stars. So what we need to do, we need to consider a position over here, and the other position will be at an infinite distance from both these stars, wherein the potential energy of this object, that is this meteorite, will turn out to be 0 because of these two stars. Okay, are you getting my point? So I just need to calculate both these things, and finally I'll be in a stage wherein I've got the answer. So let's say suppose it has a velocity v. It has a velocity v when it is situated at their common center of mass. Now we need to calculate the minimum velocity, right? So minimum means that at infinity its velocity should become equal to 0. It should have a velocity that this velocity should be that much enough that this meteorite from this position is able to reach a point which is infinitely away from both these stars. I am again repeating myself. एस्केप वेलोसिटी का मेन कॉन्सेप्ट ये होता है कि यहाँ पे इतनी वेलोसिटी दे दो कि इन दोनों के इन्फ्लुएंस से इतना दूर चले जाए जहां पे इन दोनों का इन्फ्लुएंस ही ना हो, और इन दोनों का इन्फ्लुएंस कहां नहीं होगा, एट इन्फिनिटी. सो एट इनफाइनाइट डिस्टेंस फ्रॉम बोथ दी स्टार्स ये मास वहां पहुंच जाएगा जहां पे इन दोनों का ग्रेविटेशनल इन्फ्लुएंस है नहीं, एंड व्हाट आई विल बी गेटिंग इज द एस्केप वेलोसिटी, द मिनिमम वैल्यू ऑफ एस्केप वेलोसिटी. अब उससे ज्यादा कुछ दूंगा, सो व्हाट दिस मीटेओराइट विल हैव, वो इनफाइनाइट डिस्टेंस पे जाने के बाद भी इट विल हैव अ वेलोसिटी इन इट. सो हमें वो नहीं कैलकुलेट करना, वी नीड टू फाइंड द मिनिमम वेलोसिटी. सो लेट्स quickly solve it. So what will happen, we will be just using work energy theorem. See, the concepts of work energy theorem are applicable over here. So I told you over there itself, work energy theorem is applicable throughout physics 11 12. It's a very important theorem. So let's solve it. So delta K plus delta U will be obviously equal to 0 since no non-conservative forces and external forces are in action. So delta K plus delta U will be equal to 0. Now what is delta K? So at final point I have said, because I am calculating the minimum escape velocity, so at final point I have assumed that the velocity is 0. So the velocity finally is 0. So my kinetic energy finally is 0. And what about the initial kinetic energy? So initial kinetic energy I have considered to be V velocity. So it will turn out to be half mv square. Okay, fine enough. You have calculated delta K. Now what about delta U? So delta U at final point will obviously be 0 because of both these masses. So finally delta K is also 0. But what about the initial point when this mass, this meteorite is situated over here at the center of mass? So over here the potential energy will be how much? I can easily calculate here. I can easily calculate minus Gm into mass of the meteorite. Let's say this mass to be m dash. Okay. So G, small m, this m dash into this r. And we need to multiply it with 2. Reason being, because of both the masses, it will have the same gravitational potential energy. So it will be 2 times minus of G m dash into m by r, and r is obviously given to us. It is given to us as 10 raised to the power 11. So this is the case, and obviously this will be equal to 0. So you now people must be understanding this m dash. Okay, this m dash was of the meteorites. This m dash will get cancelled and come over here. So finally I'll be getting the value of v square, and v square is in turn turning out to be, v square is equal to, this minus will go over here and will turn out to be positive. So Gm upon r, this 2 will multiply over here. So it will be 4G mass of the stars upon r. I just need to calculate that, and I can easily do that. Right now is the calculation part. Just take the under root. What is the value of G? G has been given to us 6.67 into 10 raised to the power minus 11, first class. Now what is the value of M? M has been stated to us as 3 into 10 raised to the power 31. I can easily put it over here. What is the value of R? R is given to us as 10 raised to the power 11. Why not, sir, 2 into 10 raised to the power 11? Because that was the distance between both the stars, and I need to consider the distance from the center of mass with the star. So it will be half of that. Okay, fine, sir, fine, perfect. Now, okay, 1 4 is also remaining. 1 4 is also here. This 4. Okay. So now what we'll be doing? We'll be taking approximation. We'll be using our brain and finding the result. Don't ever try and do multiplication and do a exact value of a common under root. Okay. Such kind of things are actually to test your skills, to test your mental ability. Nobody is interested in the precise value of the velocity over here, right? They just want to know the tentative answer, and obviously in the answers also you can see there are so many variations. Over here it's 10 to the power 5, it's over here it's 10 to the power 4, and 1.4, 2.8. So nobody at all is interested in the exact value. Okay. So now let's see. Can we find the exact value? Yes, we will definitely try. So 10 raised to the power 11 will go upwards. It will become 10 raised to the minus 22. It will come outside, and it will become what? It will become V is equal to, and this 4 will also come outside. So 2 into 10 raised to the power minus 11 comes outside. Now what about this 10 raised to the 31? It's an odd root. It's an odd value. So what I can do, I can put 110 over here, 66 it will become, and 30 will come out, and it will become 10 raised to the power 15. Okay, sir, perfect. Now this 66, I can write it to be 66. As it was mentioned to it, take it as 6.6. So I will be just eliminating this 7. I'll be keep only 6.6. 66 into 3. Now what is 66 into 3? What is 66 into 3? So sir, 66 into 63 is 180, and 63, well, it is turning out to be 208. Okay. Can I consider that 208 to be nearly equal to 200? Because obviously the values are not that precise, right? Yes, you can definitely. So consider this value to be nearly equal to 200, and what that will turn out to be, that 100 will come out and become 10, and that root 2, as we very well know, it is equal to 1.4. So what I can do is, this 10 raised to the minus 11 will give this value as 10 raised to the power 4, and that ton coming out from here, it was equal to 200, right? So this 10 will come out, and 10 raised to the power 4 plus 10 raised to the power 1. So it will turn out to be 4 plus 1, 10 raised to the power 5. So this 10 raised to the power 5 comes out, and over here that root 2 is also remaining. What I am doing is I am considering this value to be nearly equal to 200. Okay, right? I am just trying and develop your mental skills. Okay, just try and do these calculations as I am doing, because this will actually save a lot of your time. So 66 times 3 is near about 208. Consider it to be 200. 100 will come out, 10 raised to the power 1. this will become 10 raised to the power 6, 16, 16 minus 11 is 10 raised to the power 5, so 10 raised to the power 5 remains as it is. 2 was remaining, so root 2 is 1.4, 1.4 into 2 is 2.8, so finally I am with the value that it will be 2.8 into 10 raised to the power, not minus 5, 5. So is it the answer? Yes, it is, sir, exactly. So was I changing the answer? No, it was there in the option. It was asked in JEE Main 2019. So I didn't change it, but basically what I mean to say is the question, the examiner which has actually created this question for you people was also wanting this approach only. So this is what I want you all to learn, how to do mental calculation, save time, and just look at the options first. Yeah. Whenever I am about to solve a question, just have a look at the options also. Are they precise or are they varying differently? So over here, as you can see, there was so much difference. So there was no need to calculate precisely. A mental calculation and oral calculation, and with the help of approximation, you could have easily found out what was the value of this velocity in this case. So I suppose you all must have got this concept. Now let's move ahead and talk about this question, a very simple question, very easy one, but it also made the students feel trouble. So let's solve this. A satellite is moving with a constant speed v in circular orbit around the earth. Okay, so around the earth it is moving in a circular orbit and it has a constant velocity v. Okay, no problem. The object of mass m is ejected from the satellite such that it just escapes from the gravitational pull of earth. At the time of ejection, the kinetic energy of the object is okay, no problem. So what happens is, what they're saying is, but I can just find the answers as well looking at it, and I suppose so many of you must have also got, but this also created confusion among students, है ना? So what this is saying is, satellite is moving, obviously a satellite is moving with speed v in a circular orbit, very nice. Now an object of mass m is ejected from the satellite, so now the satellite has ejected a mass m, okay. So from the satellite such that it escapes from the gravitational pull of earth. So now if a satellite is revolving around earth at a radius r and now it ejects a mass, okay, so that mass for the moment will also be in the orbit which is r distance away from earth, right? So at the moment also this object is at a distance r, right, and from here it has been provided with a velocity because of the propulsion given by the satellite. So now it will have a velocity for sure, and much more than v which was capable enough to make the satellite move in a circular orbit, obviously it has to be, or else it will again move in a circular orbit only. So how much that velocity should be such that it escapes the gravitational field of earth? It is hinting towards escape velocity only. So the velocity provided to this mass over here should be equal to escape velocity. And now what is the value of escape velocity? So the value of escape velocity is root 2 times orbital velocity. Okay. So that means at r distance from the center of earth, an object orbiting around earth in a circular orbit will have this much velocity, and it is already provided to us. The satellite was doing that, right? So the velocity of satellite is obviously what? VO, orbital velocity. So now root 2 times VO is what? Escape velocity. So now this mass has been provided with escape velocity. So now what will be its kinetic energy? The result is pretty simple. The kinetic energy of that particle or object, whatever it is, will be equal to half m into this velocity which is stated over here, that is root 2 times v whole square. And I know all of you must be knowing the result, it is mv square. So is it the option? Yes, it is. A very simple question, a very simple question, and the result is in front of you. We got the right answer, asked in JEE Main 2019. A very simple question, okay. So if you're loving this expression, yaar, give a thumbs up. I really need that. That's my fuel that gives me the energy to express myself in such an interesting manner and bring so good content for you people, okay. And also, if you wish to get updates on a timely basis, what you need to do, you need to subscribe to this channel, okay. On subscribing it and hitting the bell icon, you will get regular updates about all those interesting happenings which are occurring. Basically you are at home, you don't have to go outside, so let's use this time, right? We are at home and we can watch, either we can watch some dance videos or music videos, or also we can watch some educational videos, right, which are presented in front of you for you people. And obviously these lectures are not for fun, but they are fun with physics, or knowledge with fun. So in a funny manner, we'll be actually expressing all the details, all the concepts of physics which are relevant for your existing preparation of JEE Main. So what else you wish for? This is a win-win situation for you people. So do watch them. They are made for you people, and they're specially curated for you people so that your preparation goes next level and you definitely ace JEE Main. Okay, now let's move ahead and solve this question again of approximation, but now the values are precise, much precise. Okay, so in this case we'll be getting into that mathematician type and we'll be solving those cases very precisely, because as you can see, the options are 194.32, 195.32, 194.6 and 195.66, and obviously anybody knows that the weight of the object at the pole is obviously lesser. No, not lesser, it's more when I compare to the weight of that object at equator. And the only reason is we are not at all concerned about the shape of the earth over here. Okay, the shape of the earth is geoid in shape, so it is much wider at the equator but less wider at the poles. The concept is not about that. The question is not at all telling us to imagine that manner. The only thing they want us to imagine is that because of the rotation of earth, this reduced weight is occurring. So the weight over here is more, the weight over here is less, and this lesser weight is because of the presence of a centrifugal force. Which force? Centrifugal force, which will be occurring in a backward direction, that is out of earth. And why this centrifugal force concept is arising? So basically centripetal force is only centrifugal force, but it's just the frame of reference which actually takes into action what centrifugal force should be. It's just kind of a pseudo force. So basically you will be observing things while standing on ground, right? While standing on ground, you are observing that what is the weight of mine. So for you standing on an accelerated frame which is rotating, that is earth, so you will have to apply a centrifugal force in outward direction. So there will be the application of a centrifugal force, and that will be equivalent to what centripetal force is. So this m omega square r will actually instead decrease the value of your weight. It will decrease the value of your acceleration due to gravity. It will be decreased by omega square r, and this is the reason why you will have a reduced weight. Now all the options have a reduced mass here. All the options have a reduced weight. So which of them is right? So we need to be very specific while calculating the values. So now let's do it. So it is given to us that the weight at poles is 196. So basically mg, what is the mg? At poles, yeah. At poles, now what is the direction of m omega square r? So it is lying on the axis of rotation. There is no concept, the distance r. R is what? The distance from axis of rotation. So there is the distance from axis of rotation is 0. So over here, the m omega square element is equal to 0. Okay, so there is no element, no decrement in the value of mg because of the presence of rotation of earth. So the weight remains as it is, that is equal to mg. Okay, so we need to find the weight over here. So what will be the weight over here? Let's quickly calculate. So W dash will be equal to, what is the weight, actual weight, minus m omega square r. Okay, fine enough. Now what is this value W? It is given to us, it is 196. And what about this m omega square r? M omega square r, what it is? So m can be easily calculated. It will be 196 upon acceleration due to gravity, that is 19.6. So 196 by 10. Okay, fine sir. Into omega square r. Now what is the value of omega? What is the value of omega? So omega is 2 pi upon t. Now what is t? It is 24 hours, right? The rotation of earth. So 24 hours, and take it into seconds, so it will be 3600. This will turn out to be 2 pi upon t and whole square. And what is the value of r? It is 6400 kilometers. So that can be written as 64 into 10 raised to the power 5 meters. I suppose you people are getting क्या बोल रहा हूं मैं, ठीक है? So ये हो गया. Now we just need to solve it, and इसमें भी I'll tell you how approximations we'll be using. So first just take 196 by 10 out of it. Okay, so this will turn out to be 10. This will also turn out to be 10, right? Is it turning out to be 10? Yes, it is. Okay. No, just wait. Let's just calculate the value of. This this entire stuff. Okay. So now what is the value of this? How can I do that? I'll be just breaking this up. So this 2 square will become 4 and this pi square, always remember pi square is nearly equal to 10. So I'll be replacing 10 over here. This I'll be writing 24 into 24, 36 into 36, and this 10 square I'll be writing as 10 to the power 4. So what this term will turn out to be 196 minus 119.6, I can write it like this. So it will turn out to be 4, pi square is 10 only, divided by 24 into 24 into 36 into 36 into 10 raised to the power 4, right? This 100 square will become 10 raised to the power 4, okay. And this 64 into 10 raised to the power 5 can be written like this. And the reason I have written like this is because I will be cancelling terms now. So as you can see, 8 8s are 64 and 8 3s are 24. Now again 8 3s are 24, okay, fine sir. Now this 4 can also get cancelled by this 36 by value 9, okay, perfectly fine. Also this 10 raised to the power will get cancelled by this, so it will turn out to be 100 divided by 3 into 9 into 36. Yeah, one more thing. I can do one thing. Over here it's 100 coming, right? And over here it is 36 into 3. So 36 into 3 is nearly equal to 100. 6 into 3 is nearly equal to 100. The term turns out to be 108. I can consider it to be 100, right? I can consider it to be 100. So I can just eliminate this with this 100. And now what I am left with is 196 minus 19.6 divided by this 9 3s, that is 3 into 9. Okay, this thing I can do. So this entire expression has converted to this, and this thing I can do. So 9 gets cancelled by this, it becomes 2.178 something, and 3 it turns out to be 0.72333. So 196 point minus 0.72, it will obviously turn out to be 195.3 something. So is there any option near to it? Yes, there is. Let me see, am I correct? Yes sir, you are absolutely correct. You are absolutely correct, and we got the final right answer using this approach, okay. So now this question is basically a homework for you people. You need to solve this question. It's a very simple question wherein we just need to find the ratio of the escape velocities, okay. So there are two planets of masses m by 2. They have radii r by 2, and what we need to do, we just need to calculate what is the value of n, and I can tell you the answer even, the answer is 4. But give it a try from your end. Give it a try, you will definitely love this expression, and this will be the end of this lecture. So before ending, I just want to quickly give you a glimpse about this app. You can go in the description, check the link for Extramarks the learning app, and trust me guys, this is a very wonderful user interface, okay. As you log in, you can actually access so many questions, unlimited amount of questions on whichever topic you like. You have these filters of subject, class, and you can easily apply them and solve questions accordingly. Apart from that, you also have the availability of tests. So we have the questions, we have the tests. Now what you need more? You can test yourself by giving so many trending tests, so many score booster tests. Even you can create your own test, guys. You can create your own test according to your topic, according to your level. So what more you need? Download this, give it a try. You will definitely love it. Now we'll be meeting in the next lecture with a very new topic of mechanical properties of fluids and solid. Very interesting topic, very nice topic, and I'll be presenting. Remember the date, 31st January, the time 3 p.m. We'll be sharp at 3 p.m. meeting in the next lecture with more such new videos, more such new questions of this unit. So till then, bye bye, happy learning, all the best.